Hey everyone, welcome back. Today we're going to be continuing with the same topic that we started a couple of lessons ago, which was graphing lines or linear functions. So in the first video of this unit we just sort of introduced the topic and got a little bit of an intro to graphing. So we talked about what the Cartesian plane is, the x-axis, the y-axis, and went through an example. And last lesson we went through a couple more examples of graphing lines. Now, just to refresh your memory on what we did last lesson, you don't have to write this down. So we had our axes like this, right? We had our x-axis over here, we had our y-axis up there, and then we plotted two lines. So one of them had points looking something like this. That might not be a perfectly straight line, but hopefully you get the idea. And the second one had points that were more like this. Now, actually, if I remember correctly, the graph that we drew last lesson didn't have neither line passed right through the origin, but that doesn't really matter. So if I remember correctly, we graphed, what did we do? We did y equals x plus 2 and y equals x plus 1, right? So nothing passed through the origin the way I've drawn it here, but we had something like this, right? If I shift the whole x-axis down a little bit, so if we have something that looks a little bit more like this, this is more like what we had in our diagram from the last lesson. Right now, obviously, this is just a really rough drawing right now, so it doesn't look exactly like what we did. But what we could see when we were graphing those two functions, those two equations, so we had y equals x plus 2 and we had y equals x plus 1. Now the only difference is in the number that we added on to the end of each function, right? So y equals x plus 2, that corresponds to this line right up here, and y equals x plus 1 was for this line down here. And so all you can, what you can see is that the only difference between the first and the second equation that when we graphed the lines was that there was just this vertical shift between the two lines, right? So you could plot points in the same place except for that vertical shift, and that shift was the same every time, right? So the gap between these 2 points on these 2 lines is the same as the gap over here, which is the same as the gap over here, which is the same as the gap over here. So these 2 lines were parallel. They were always the exact same distance from one another, like train tracks. So what we saw from this is that we weren't multiplying x by anything, right? So if you remember back to the first graph that we did in this unit, that was 2 lessons ago, I believe, that was y equals x over 2. And if you, it's a little bit hard to see when you're just comparing, you know, one graph that you did one day to a different graph that you did another day. So don't try and compare them right now necessarily, but what we're going to do today is we're going to explore what happens when you multiply or divide the x by something. So the very first day we took x, we divided it by 2, and we got some line. And then last lesson, we didn't touch the x itself. We didn't multiply or divide x by anything in either of those equations. All we did is we added on a different value to the end, and we saw that it gave us this vertical shift, this vertical displacement between the 2 lines. So what we're going to do this time is we're going to explore what happens if you multiply x by something, or if you divide x by something. So if we did, instead of y equals x plus 2, what if we did y equals 2x plus 2? So like, what if we did something like y equals 2x plus 2? And you know what, we won't even worry about the plus 2 right now. What if we did something like y equals 2x? You can't really see the red, let me switch back to black. What if we did something like y equals 3x? What if we did something like y equals x divided by 4? What will each of these things give us when we try to graph them? So that's what we're going to figure out in today's lesson. So let me erase all of this. Hopefully you haven't been copying a bunch of this down. We're going to go over all of this again in a few minutes. I have three colors with me. I've got black, red, and blue. The red, I'm not sure quite how well it's turning up on the screen. It seems to be okay on the whiteboard, so I'll maybe use it, but maybe not. Let me just give it another test here. We've got red. Okay, that's not terrible. Let's see how this blue goes. Okay, the blue's also fine, but in comparison to the black, okay, hopefully it's not terrible. Okay, yeah, so I'll stick to doing most of it in black like last time, but then when we draw the lines, we'll draw them in black, blue, and red. So if you have any extra colors, you can use those. If not, when you're plotting your lines, I'm always going to use these big circular dots, but if you need to differentiate and you've only got one color, you could do boxes, or you could do like filled in boxes, or you could do like circles that aren't colored in. So you could draw your lines, in some way that you can differentiate between the 2 or 3 lines that we're going to be doing. So today we're going to be graphing 3 lines all on the same Cartesian plane, all on the same set of axes. So try and figure out a way that you can differentiate between them if you're not using different colors, or you could call them like line A, B, C, and then label the equations A, B, and C, something like that, so you can figure out what's going on. If you need a title for today's lesson, we'll just call it More Graphing Practice. So that's an R. More graphing practice. Let's make that, a smiley face. Great. Okay, so we're going to do some more graphing practice. So what I'm going to do is I'm going to draw in my handy dandy Cartesian plane. Oops, that's terrible. I'm going to draw in my axes right now so that I don't have to worry about it again later. For you guys, I recommend, and what we're doing in today's lesson is we're just going to be plotting all 3 lines on the same one set of axes. So you can draw one nice big one, make it take up like half the page or something. You're going to need a lot of room to do this. So make it nice and big, and when you're putting in your tick marks for each one, have it go up to about 8 in both directions. So put like 8 tick marks across the x-axis and 8 tick marks across the y-axis. So if I do something like this, then I could put one there, put one here, put one here, put one there, one there, one there. I'm hoping these are roughly equidistant from one another. We're going to hope for the best. Something like that. So we got 1, 2, 3, 4, 5, 6, 7, 8 going across the bottom. We got 1, 2, 3, 4, 5, 6, 7, 8 going up, and we got our 0 point right in the middle there. So hopefully you guys can see that all right. Let me see if I can scooch this a little bit closer. There we go. I just don't want to cut off any section of the whiteboard from what you guys need to be able to see, because we kind of use the whole board now, like kind of corner to corner, right, except for the title. So if I have to cut something off, I'll cut off the title. But yeah, so your axes should look something like that. Try and get up to 8 in both directions, because we're going to be using quite a large section of the graph for this one, because we're plotting 3 different lines on it. So I'm going to tell you what the equations are. We'll do one at a time, and actually in order to have the equations on the board but somewhere where they're not going to get in the way, I'm going to get rid of the title just so that we have a little bit of extra room. So the 3 equations that we're going to be graphing. So just a recap of yesterday, don't write these 2 equations down. Yesterday what we did was y equals x plus 2 and y equals x plus 1. So we weren't messing around with the x itself, we were just adding different values. We could have subtracted something instead. We could have done y equals x minus 2 or something, or x minus 3 or x minus 5, and seen how that changes the graph. And so We'll come back to doing more such examples where we're fiddling with different parts of the equation. So last time our focus was on these numbers being added on at the end. Today we're going to be focusing on something slightly different. So don't write those ones down, but write these next ones down. Today the equations that we're going to be doing are y equals 2x, so 2 times x, y equals x, and y equals 1/2 x. Now this third one over here, this 1/2 x, if you want to rewrite that as y equals x over 2, that's also fine. Oops, there goes my blue marker almost. Y equals x over 2. I almost lost that. And so these are the three equations that we're going to be plotting today. So we got y equals 2x, y equals x, and y equals 1/2 x. Or you could rewrite that third one like this. So this one we've already graphed. We graphed this one in our very first plot of this unit. We plotted y equals x over 2. So that one should hopefully not cause us too many problems. And what we'll do is we'll plot all three of those on this same set of axes over here. And then we'll see what happens when you change the number that you're multiplying x by. So if you notice, we're in one of these, we're not changing it, we're not touching x at all. It's just y equals x, so whatever number you put in is the same as the number that you're going to get out. So maybe we'll actually start with that one, and then we'll plot these two, and we'll see what the difference is. So let's start. We'll start with plotting y equals x. So let's make our table down here so that we got some values that we can plug in. So you're going to have to make 3 of these tables. I'm going to back this up just a little bit so that we got some room. All right, cool. So we've got our x column and we've got our y column, right? So we're going to just pick, we don't have to pick that many. Yesterday I think we were picking 4, so today we'll stick with that. We'll pick 4 different x values, we'll calculate the y values, and we'll throw them on the graph. So if we start with the equation y equals x, this is telling us that when you've got that that handy-dandy machine, don't draw the machine, or if you're going to draw it, please don't draw it in the middle of your graph. So here's our handy-dandy machine. If we're dealing with y equals x, that means whatever number you put in for x, you're going to get out the same thing for y. So if I put in a 2 for x, I'm going to get a 2 out for y. If I put in a 6 in for x, I'm going to get a 6 out for y. If I put in pi, I'll get out pi. If I put in -1,000, I'll get -1,000. So whatever I put in for x, I'm going to get the same number out as y. So we can basically just choose whatever numbers we want, and we know what the y value for each of those is going to be, because it's going to be equal to whatever number we put in. That's only for this particular equation. For y equals x, we're not multiplying it by anything, so the number we put in, right, we get to choose that number. And because it's y equals x, and it's not 2x or x plus 2 or anything like that, we're not adding anything to it, we're not subtracting, we're not multiplying, we're not dividing. It's just whatever number you put in is the number you get out. So if we just pick a few values, instead of doing 0, 1, 2, 3, just because those are all scrunched in, I'm going to skip every other number. So I'm going to do 0, 2, 4, and 6 instead as my x values this time, just so that we use up a little bit more of this graph. And it'll help us when we're trying to actually draw in the line. Now I'm debating, do I want to put in those dotted lines? Maybe I'll put in some of the dotted lines, but not all of them. So we put in something like this. You don't have to put in these dotted lines, especially if you're doing this on lined paper. You should already have those horizontal ones kind of made for you. I'm putting in some of these just as sort of a rough guideline. Hopefully that's not too far off from kind of what we're looking for. Something like that. I think that'll do. I think that'll do as a sort of rough guideline. So I'm not going to put in a whole bunch more of those because I don't want it to take up too much space or sort of clutter up the graph too much. So those are just a few dotted lines as guidelines for me because I don't have any of the lines that you guys get on your paper. So, okay, so that's our graph sort of set up over there. And now we just need to figure out some points that are going to end up going on that graph. So let's remind ourselves, this is the equation that we're working with, right? Y equals x. That's the second of the three equations that I wrote down. So here, whatever value I put in for x, it's going to spit out the same thing for y, because I'm not multiplying it, I'm not dividing it by anything, I'm not adding or subtracting. Whatever I put in, I get the same thing out. So if I put 0 in, this is telling me that y is equal to, and then my x value is 0, so y is equal to 0. It's pretty straightforward. You can't get more straightforward than y equals x when you're dealing with graphing a line. So whatever I put in is going to be the same thing I get out. Right? If I set my x value equal to 2, then I just plug that into the equation, and it's telling me y is equal to 2. When I choose an x value of 2, it's telling me that y is going to equal 2. So for this particular equation, whatever I put in is what I get out. So that means I could just fill out these ones by sort of eyeballing the rest of the column, or by eyeballing the pattern. Whatever the x value is, the y value is going to be the exact same thing for this particular equation. So that only works for y equals x. If you're doing anything else to x, you're going to have to worry about adding something or dividing something or whatever the equation tells you to do. But for this one, it's fairly straightforward, so let's go ahead and plot these points. So we start by figuring out where 0, 0 is. So 0, 0, that's this point where x is equal to 0, y is equal to 0, is the point where the two axes cross each other. So that's right there at 0, comma 0. If you really wanted to properly label it, you'll label it 0, comma 0 like that, and try and write it close to the point, but don't really worry about the labeling today because we're trying to put 3 lines all on the same thing, so it'll be a little bit messy that way. Alright, so now let's look at the next point. So the second one down here, we've got x is equal to 2, y is equal to 2. So just again, in case you wanted to note that down somewhere, that you'd write it down like this, where your x value goes first, your y value goes second. And to figure out where that goes, both of them are positive numbers, so we're going to be moving. So if x is positive, we're moving to the right, and if y is positive, we're moving up. So it's going to be somewhere in this space. You can have this your graph extend out towards the left and extend out downwards. We're going to get to that in possibly the next video, maybe the video after that. But for now, we're just dealing with positive x values, so you're always moving to the right, and positive y values, so you're always moving up. So if we've got an x value of 2, that means we have to move 2 units to the right, so over to here. And then we have to move 2 units up, so we move up to about there. And we put a dot. Something like that. All right, that should be roughly at the point 2, 2. Now we can do the same thing for the third point. I'm going to go a little bit faster because we've done this a couple times. Hopefully you guys are understanding it, and this is a particularly easy equation to graph. So when x is equal to 4, y is equal to 4, so we start from 0. Because x is equal to 4, we go 4 units to the right, and because y is equal to 4, we go 4 units up, and we put a dot right there. Hopefully you can see where the pattern is, and you can see roughly where this line is going to go. If I do the last one real quickly, I'm going to do it quickly, but if you guys aren't seeing where I'm getting this from, then try and do it yourself and see if you get a dot in roughly the same place as me. Now, because this is kind of far away from both axes, I'll just sort of let you know. This point is at 6, 6. That's coming from this last pair of numbers in our table. And so we get that by going 6 units to the right over to here, and then 6 units up. So we're lining it up with this 6 over here and lining it up with that 6 over there. And so if you sort of drew a line from those two 6s connecting them, they would meet up at this point. So you drew a horizontal line going this way, a vertical line going this way, they would cross right at that point right there. So those are all 4 points, so we can go ahead and try and connect them. I'm going to try and do this in a reasonably straight line, and I'll extend it in that direction as well. And we've got something like that. So that's our first of the 3 lines. So remember, we just play connect the dots with it a little bit, and there you go. I would label the equation, but I kind of don't know where. Um, mhm. Yeah, whatever. I'll just kind of like do like a little wavy thing, and we'll say y equals x right there. Brilliant. Okay. Um, all right. Moving right along, we'll do our second one. Let's do let's do y equals 1/2 x next. Um, so if you want, you can rewrite the equation above your new table. So we'll do y equals 1/2 x, or if you prefer, you could write that as x over 2. And what I'm going to do is I'm going to use the same x values. I'm just going to erase the y values here. So I'll give you guys a second to draw that table. Now remember, you could choose any x values you want. So yeah, you guys are going to unfortunately have to remake a new table and put in these numbers again. Beauties of the whiteboard is that I can just erase it and I'm good to go. You can choose whatever x values you want. I've chosen all even numbers for this one. I'm skipping 1 and 3 and 5 because I know from the equation that if I rewrite this, maybe it's easier if I rewrite this as x over 2. These two equations are the same, right? I'm taking my x value and I'm dividing it by 2. That's what this equation is telling me, is that in order to get my y value, I have to take my x value and divide it by 2. Y is equal to x divided by 2. So if I give myself an odd number, if I choose an odd number for x, odd numbers divided by 2 are going to give me some sort of a decimal, right? 3 divided by 2 is 1.5 or 1.5. 7 divided by 2 is 3.5 or 3.5. I don't want to deal with decimals and fractions if I don't have to, so I am deliberately choosing even numbers to put in my table because I know it's going to give me nicer numbers over here. If I take 8 and I divide it by 2, I'm going to get 4. It's a much easier number to work with than 3.5, especially when I've only got limited lines on this graph. I don't want to be trying to find 3.5 in this space over here. I'd rather just look at the 3 or look at the 4 and just sort of just go based on that. So you're allowed to choose values that you think would be useful for your particular situation. Everybody likes to choose 0 and 1 because you know, if you've got a 0, 0 divided by anything is still going to be 0. Or if you had, you know, x times something, if you had like, when we're doing this one over here, if you're doing like 2 times x, if x is equal to 0, it's going to be 0 no matter what. If x is equal to 1, it's going to be equal to whatever number it's being multiplied by. So 0 and 1 are sort of fan favorites when you're trying to get a couple of points that work. They don't have to be equally spaced from one another, the x values that you're choosing. I could choose 0, 1, 10, and 100 because I like multiplying things by 10 and 100. If whatever you find easiest, you're more than welcome to go with that. The problem with the only thing that's really restricting you is how big can you make your graph over here. If I can only go 8 units over there, I shouldn't be choosing x equals 10 because then I'm going to be struggling to graph that, right? If you happen to choose like x equals like 7 and then your y value comes out to like 35, it's going to be a little bit hard to graph. Sucks. It happens sometimes that, you know, you pick a point and it's like, oh shoot, I can't really graph that the way I've set up my drawing over here. But you know, use your common sense. If your x-axis only goes up to 8, don't be choosing an x value that's bigger than 8. If your x value doesn't have any negative numbers, don't be choosing any negative numbers. You could choose 0, you could choose 1, you could choose 4. Choose anything in this list. Don't choose a decimal value for x because it's just making life harder for yourself. But yeah, so that's why I've chosen these even numbers, and that's why I'm sticking with them from the first drawing to the second one. So from the first equation to the second one, I'm sticking with these even numbers because I know I'm going to be dividing all the values by 2. So if I look at my equation, let me rewrite the equation in a way that's a little bit easier for us to understand what's going on. So we got y is equal to x over 2. So if I plug in a 0 into this equation, that means I'm getting y is equal to 0 divided by 2. 0 divided by anything is still going to be 0. So my y value is going to be 0 for this one. Right? Now, if I choose a different x value, if I choose, let's say, x equals 2, That means that that 0 in the fraction is replaced with a 2. Y is equal to 2 divided by 2, which is equal to 1. Right? Hopefully that's making sense. I'm trying not to go too fast, but since we've already graphed this exact line, I'm kind of zipping through it. When x is equal to 4, y is going to be equal to 4 over 2, 4 divided by 2, which is equal to 2. And now, usually, especially with linear functions, if you can see the pattern that's going on over here, you can just follow the pattern in the table. You don't have to put everything into the equation. If you can see, oh, my x values are going up by 2, my y values are going up by 1, then as long as you can make sure the next x value has gone up by 2, you can just make your y value go up by 1. But if we put it into the equation of x equals 6, that's going to go in here. Y is equal to 6 divided by 2, which is equal to 3. And you can see there in the corner that that pattern still holds, right? As your x value goes up by 2, your y value goes up by 1 for this particular equation. Okay, so let's plot this one. Let's see, we plotted that first one in black, so I'll put another black box around it. The second one, let's do this in red. So we're doing y equals 1/2 x now, so I'll put a red box around that one so you guys don't lose track of which one is which. And we'll plot some points. So when x is equal to 0, y is equal to 0. So that's our origin. That's this point right here. So I don't want to cover it up in red, but whatever. We'll put some red in there, something like that. I don't even know if you guys can see that. So when x is equal to 0, y is equal to 0, that's our origin point right there. When x is equal to 2, y is equal to 1. So I start from here, x is equal to 2, so I got to go 2 units to the right, and then y is equal to 1. So I go up 1 unit, and I put a dot right there. Okay? So that's our second point. Our third one, when x is equal to 4, y is equal to, when x is equal to 4, y is equal to 2. Sorry, I thought I said something differently. Forgive me, it's almost midnight at the time of recording. So when x is equal to 4, y is equal to 2. So we start from our origin, we go over 4 units for x. So x is equal to 4, so we've gone over 4 units to the right, and then we go up 2 units, so to about right there, something like that. Okay? And our last point, when x is equal to 6, y is equal to 3. So when x is equal to 6, that means we've got to go 6 units over on x, and then we go up 3 units. So we go up to about here, something like that. That looks quite reasonable, I think. So those are our 4 points for this equation, for y equals x over 2, or y equals 1/2 x. Those are our 4 points. So we can connect those with a line. So that'll, hopefully, if this comes out straight, that'll look something like this. And we can extend that in the other direction, and it goes something like that. All right, brilliant. Hopefully you guys can see that line. And I'll do this little thing again. Y is equal to x over 2. It's a little scrunched in there. All right, y is equal to x over 2. So that's 2 of our 3 lines. We're going to do one more. Last one, this one's going to be in blue, so I'll put a blue box around this before I forget. So we've got y is equal to 2x. That's going to be our last one for today. And hopefully you can kind of see where this is going, but if not, you'll understand as soon as we finish up this last one. For this one, when you're making your table, I'm going to actually change the values for x because they're going to get too big for us to graph if I leave the x values as 0, 2, 4, and 6. So we're going to get rid of all the values, and for x, I'm going to, instead of doing 0, 2, 4, 6, I'm going to do 0, 1, 2, 3. So I'm going to do 0, 1, 2, 3 for x. And then we'll figure out the y values for that based on this equation. Y is equal to 2x. So this is the equation that we're graphing this time. So first thing we need is our 3 or 4 points so that we have something to put on the graph, so that we got something with which we can connect a line. So if we start by looking at the equation, we've got y is equal to 2 times x, or x times 2, if you prefer to word it that way so that you understand what's going on. Basically, when I put in an x value, it's going to, the function is going to multiply it by 2 and spit that out as a y value. So basically it's saying y is equal to 2 times whatever number I put in, right? If I put in a 3, y is going to be 2 times 3, which is 6. If I put in a 7, y is going to be 2 times 7, which is 14. So whatever number I choose, so I get to choose that number, so we'll make that a smiley face. I get to choose that number. It'll be 2 times that number is going to be my y value. So basically, whatever my x value is, I'm doubling it. So if we go through and we plug in one number at a time, we've got y is equal to 2 times and then whatever number I choose. So I'm choosing 0 as my first x value. So y is going to equal 2 times 0. Anything times 0 is 0, so that tells me my y value's got to be 0. For the second one, when x is equal to 1, we've got y is equal to 2 times 1. 2 times 1 is equal to 2. So we put in a 2 for our y value over there. Hopefully I'm not going too fast. I'm trying to leave the equations on the board so that you can see what I'm doing. Remember, this is the equation that we're dealing with right now. This y is equal to 2x. For x is equal to 2, we've got y is equal to 2 times 2, which is 4. So if I just put in sort of in brackets here, this is x equals 0, this is x equals 1, this one up here is x equals 2. Hopefully this isn't too confusing. I know there's just equations and numbers and stuff all over the board right now, but hopefully you're following the process of what I'm saying. So basically, for this particular function, for y equals 2x, whatever my x value is, my y value is just going to be double that. So for x is equal to 3, we could put it into the equation. We get y is equal to 2 times 3, which is equal to 6. So if I've just gotten rid of the x equals 0 one, I've replaced it with our x equals 3 line. So we get y is equal to 2 times 3, which is equal to 6. So we've got our table down here. Hopefully that wasn't too quick. If there's something about that table that you're not understanding, we'll revisit this example next time. It's just that this is already almost 33 minutes on the clock for this lesson, so I want to make sure we can finish this and sort of appreciate the result that we get. So let's plot these 4 points. So we've got x is equal to 0, y is equal to 0. Once again, that's our favorite, that's our origin over here where the two axes cross each other. I don't know if you guys can see that blue dot. It looks kind of blue on the camera, but I don't know how it turns out for you guys. Our next point, when x is equal to 1, y is equal to 2. So that means if x is equal to 1, we go 1 unit to the right, and then y is equal to 2, right? We're dealing with x equals 1, y equals 2. So for x equals 1, we go 1 unit to the right, and then we go 2 units up, because that's what the y part of it is telling us. And we put our dot somewhere over there. Okay, that's 2 of our points already dealt with. The third one, when x is equal to 2, y is equal to 4. So when x is equal to 2, that means we go 2 units to the right, and then we go 4 units up, because that's what the y part is telling us. We put our dot somewhere up there. That's this dot right here. And for our last one, when x is equal to 3, y is equal to 6. So when x is equal to 3, that means we go over 3 units from the origin, and then y is equal to 6, so we go 6 units up, so somewhere about here. Something like that. All right, hopefully that looks kind of reasonable, and hopefully you guys can kind of see where this is going. So now we've got our blue dots on there. As long as you can tell the blue dots apart from the black ones, you should be able to see exactly where this line is going. And so if we connect those with a line, we get that they all line up really nicely like that. And if I just take that in the other direction, it goes like that. Great. That went a little bit wonky there, didn't it? If I try and straighten this out a little bit, something like that. Okay, it's still a little bit wonky, but I think you guys get the idea. You can see what's going on with these 3 lines. And so this one, if I try and label it, say y is equal to 2x. And that's this line right here. Brilliant. Okay, so those are our three lines. Let me bring this a little bit closer so we can see the graph a little bit better. Okay, there's your graph. So, what do we see from this? If you look at the three equations that we've graphed, we have y equals x is this black line right here. Okay? I'm going to put that marker down so I don't confuse myself. So y equals x is this black line right here. Y equals 1/2 of x, or x over 2, is this red line going over here. And y equals 2x is this blue line going up here. So what we can see is, basically what we have here is we've got x multiplied by 1/2, x multiplied by 1, x multiplied by 2. So when we're multiplying x by a bigger and bigger number, this line gets steeper and steeper and steeper. Right? Hopefully you can see where I'm going with that. If so y equals x, that's the same as y equals 1 times x, right? So we're multiplying x by 1 over here. If we make that smaller, we multiply x by 1/2, that gives us this line. But if we make x bigger, we get y equals 2x, which is this one over here. So whatever you're multiplying x by, it doesn't change the position of the line. That was what we were seeing yesterday, is that the whole line shifts up or shifts down depending on what you add or subtract in your equation. But if you're multiplying or dividing by x, or not by x, if you're multiplying x by something or dividing x by something, that changes how steep the line is. So you can have some lines that are like almost vertical, you could have lines that are going that way, like in the opposite direction, you could have a perfectly flat one, you could have a perfectly diagonal one, like this black one right here. You could have a whole bunch of stuff going on with your lines, depending purely on what you've multiplied x by in your equation. So you could probably guess that if I did y equals 3x, it's going to be steeper than all of these lines because I'm multiplying x by an even larger number than what we've dealt with. So we've got y equals x is here, y equals 2x is here, y equals 3x is like this, and y equals 4x is like that, and y equals 10x is going to be really steep. It's going to be going like almost vertically in the graph that we have. It'll be something like this would be our y equals 10 graph. And if I make my number smaller than 1/2, I could do 1/4, which would be something like this. Like it would be another shallower line. I could do 1/8, it'll be an even shallower line. And as I make that value smaller and smaller, the line's going to get flatter and flatter down here. It's going to be almost perfectly flat until I get to y equals 0. Like 0 times x, that would be a perfectly flat line. But if I've got just a fraction, 1 over 1,000 will be an almost perfectly flat line. 1 over 100, also almost a perfectly flat line. Y equals 1/2 of x is going to be this red line right here. Y equals x, black line. Y equals 2x, blue line. Y equals 3x would be even steeper. Y equals 4x or 5x or 10x would be even steeper that way. So hopefully you can see from these three lines that we've drawn here that changing what you multiply x by only changes the steepness, and the lines will all still intersect at some point. In this case, they'll all intersect at the origin. We'll talk a little bit later when we're dealing with some more complex examples about where the lines intersect with one another. But that's a problem for another time. So hopefully this is making sense. Hopefully yesterday's thing is making sense of what happens when you change the numbers that are being added together. Next lesson, probably next lesson, and if not next lesson, the one right after that, we're going to be taking all that information and sticking it together and examining the equation of a line and what all the different components mean. So what we're going to be able to do after we finish next class or the one after it is we're going to figure out how to plot these lines on the graph purely by looking at the equation without having to do this point by point stuff with the table. You look at the equation, you throw it on the graph. It's going to be that easy by the time we're done examining the equations. So as always, if you guys have any questions, get in touch with me through email or a comment or something like that. Otherwise, I will see you all in the next video. Have a good one.